Hello there everybody, hello and welcome to the last day, day 5 of this basic ROS learning week. So first of all, thank you all for tuning in one more day. We are on the last day. Yeah, I know it's very sad, it's a pity that this week of learning is going to end today. But well, all good things come to an end sooner or later, so this day was going to come. We all knew that, but yeah, let's face this last day with optimism and with lots of power in order to complete this week and to put together and to train, and practice everything you've learned during this week. This is the main goal of today. Yep. So as always, I want to start here drinking a little bit of coffee from my ROS developer cup. And once I have done this, I'm set up to start. So the first thing, let's have a look at the schedule, which is coming to an end. And basically here we have the schedule of the week. So we've already covered on Monday Linux for robotics, on Tuesday Python for robotics. Then many of you have done the exam for Linux and Python. There were some problems there which should be solved today. So if you try to grade your exams, you should get a good autocorrection. So there were some problems there with the autocorrection script, which should be solved. Yeah. So I already posted a message in our forum, but I wanted to say it also here. So on Wednesday we were working on the ROS Basic concept. So we learned a little bit about ROS, what is ROS, some basic concepts you need to know, like what is a ROS package, a ROS node. Also, we created our first ROS program. Yeah. And then yesterday, on Thursday, we had the core day of this week, where we were talking about ROS topics and messages. Yeah. So we learned about ROS publishers, about ROS subscribers, and also about messages. But we didn't have time enough to finish because there were too many concepts, too many new things to learn. So we are going to finish today what we started yesterday. Yep. And finally, I'm going to present to you the ROS Robotic Challenge, which is a challenge where you are going to be able to practice and to put together everything you've learned during this week. Yeah, this is going to be in the second part of the class today, where I'm going to present to you this challenge, and I'm going to let you do it, and I'm going to be here with you solving your doubts. Yeah, so let's go for it. First of all, I've said in the first part we are going to be finishing what we did today. So let's go to the ROS Development Studio all right now, and here you should have all the projects for all the days, but in this case we are going to start working in the day 4. Yes, later for the second part of the class I'm going to share with you the project for today. Yes, but for now I want all of you to open the basic ROS Learning Week day 4, ROS topics and messages. Yeah, so please come here to the ROS Development Studio and open this project. So I'm going to click here and the environment is going to start loading. Yep. So at this point, let me have a look at the comments and see how you are doing, guys. Okay. I can see a message here that you say, I just have day 3. Okay, yeah, it's there's the possibility that someone didn't come yesterday. So I'm going to share here the link from yesterday for day 4. However, if you didn't attend on day 4, it's going to be hard for you today, yeah, because we are going to base everything on these concepts. But however, I'm going to share with you. Let me come here. Okay, so here I have sent the link of the project for day 4. Yep. Let me switch here to my view. All right, so I am checking here your comments. Let me know if cannot see your screen. What do you mean? Abe Kang cannot see your screen. Everything seems to be good here, so I don't know. Already there. I loaded week 4 earlier. Says Engineering Nation. Excellent. Loading. Okay. Still the Kiran So says, still the question of why package is being created under Kaking Workspace SRC, not under Kaking Workspace Build or Devel. Can you please provide a feedback on this? Yes, that's because inside the Kaking Workspace you have three folders, yeah? The Build, the Devel, and the Source. The Source is the one that is going to contain the packages, yes? Then when you compile your packages, all the compiled files, libraries, etc. are going to be placed in the Build and Devel folders, yes? So the Build and Devel folders are the folders that contain all the compiled files, let's say, yes? But in the SRC is where you are going to develop to create your ROS packages. Tauhid Ahmed here says, yesterday we did not compile the package using Katkin make. Yep, that's true. Why we didn't compile it? Because we didn't need to compile it in this case, yes? We didn't need to compile it because we were using a Python file. Yep, so we were working with a Python script, and Python scripts don't need to be compiled because they are compiled on execution. Yeah, they don't work like a C++ script, for instance, which needs to be compiled and to generate the executable, yes? Python files are different. So if your package only contains a Python script, it's not mandatory so it's not needed to compile it, yep? But today we are going to create a custom message and we are going to need to compile the package. So we are going to see that in a moment. I can see a message here from Carlos Araya Jimenez. Hi, I had an issue with the test. The system marked some item as incorrect, even though my program does exactly as requested. Does this mean I won't be able to get a certificate? No, I just explained this a couple of minutes ago. So there were some problems in the autocorrection system, which we have fixed today. So try to correct it again today, and you should get the correct mark. So assuming that your files are correct, you are going to get the proper mark. So don't worry. Try to correct it again. Okay, Madame Sol, no day 5 project today. Yes, I'm going to share it later. All set and running. Okay, thank you. Yes, 100%, I can see here. Ready for takeoff. True, we need day 4. Okay, I already explained this at the beginning. So, guys, we are going to start with day 4 because we need to finish the explanation and explaining some concepts. And when we finish explaining the theory from day 4, when we finish that project, we are going to move to day 5. Yes? Loaded. Okay. Loaded. Okay, great. So let's go with it. All set, loaded, excellent. So let's start. I see that everybody is already set and ready to start. All right, so very quickly, let's do a super quick summary of what we did yesterday. Let me make this bigger. So we started with topic publishers, yeah, explaining what is a publisher. Basically, a publisher is a ROS program that publishes into a topic, yeah? As simple as that. Then what is a topic? Well, a topic is a channel where you can either put information into or get information from it. Yep. So that's a topic. Then this information is represented in form of a message, of messages. Yes. So a topic, it's the container, it's the channel, and the message is the data that we place or get from this channel. Yes. Then, with this being said, a topic publisher is just a ROS program that publishes a message into a topic. Then, A message, it's the data that we are going to send through this topic, yep, or that we are going to read from this topic. And a topic subscriber is just a ROS program that gets a message from a topic, yeah? So it gets and reads this data, this information from the topic, yes? So more or less we ended here. We ended explaining the topic subscriber with the callback and everything, and doing these examples with the ROS topic echo, ROS topic pub. Yeah, remember that we launched this program, but nothing was happening because we weren't publishing into the topic. Then we used the ROS topic pub command in order to publish into the topic, so then we were able to get the messages, yeah? So we did this demo, and basically we ended here. So now what we are going to do is to do these exercises, exercise 2.2 and 2.3, and for the exercise 2.3 we are going to need to create a custom message. And for this we are going to be covering this final section here. Yep. So let's go by parts. First of all, we are going to do exercise 2.2. Yes, I'm going to give you some minutes so that you can start doing it and thinking about it, and then I'm going to do it with you. Yes, to see so that you can see the solution and how to do it. Yep, step by step. Then basically here we have create a package that launches the code, modify the code in order to print the odometry of the robot. So here, from yesterday, let me open here my IDE in order to visualize my files. Alright, apparently this is not loading properly, so in case that your IDE doesn't load properly, like this, remember, yeah, just click on the refresh button here, and it is going to load, yes? So if you get this circle here and the IDE doesn't show, click here on the refresh button and it is going to show properly, yeah? Alright, then here in my Catkin workspace, we created this topic subscriber package, no, topic publisher, no, topic subscriber package, yep, which subscribed to the, let me open here my file and let me make this a little bit bigger, let me organize my environment. Alright, yeah, so here I have the program, the same program I have here, yes? Then in this program we were subscribing to the counter topic, yes? So basically what we need to do now is to modify this code here, the one in simple topic subscriber.py that we created yesterday, modify the code so that instead of subscribing to the counter topic, we subscribe to the odom topic, yes? First of all, let me launch the simulation so that we get all the topics. Remember, in order to launch the simulation, you have all the steps here at the top of the notebook. Yeah, how to do it? You need to come here to the simulations menu, click on choose launch file, and then here from the Turtlebot Gazebo package, which you can see here highlighted in black letters, from the Turtlebot Gazebo package, choose the main.launch file. Yes? So this is going to automatically start my Gazebo simulation. Here I have it. This is starting to load. Let me place it somewhere here. And meanwhile it loads, I'm going to open a new shell. Yes, tools, here from the tools menu I choose the shell option, which is going to open a web shell, a new web shell. Then let me refresh this as well to show better the simulation. Okay, there we go. Here I have my simulation loaded with the Turtlebot and the wall. And here if I do a ROS topic list, remember this topic, yeah? This command, sorry, ROS topic list, to get all the a list of all the topics running right now. Then here we can see all the topics that are being, that are running, that are active right now, yep? Then here we can see a topic which is named odom, yes? So basically we are going, what you need to do is to modify this code, this simple topic subscriber.py script, in order to, instead of subscribe and to the counter topic and print the counter topic message, Instead, we are going to subscribe to the odometry message and print the odometry message. Yeah? So that's what exercise 2.2 is basically requesting and what I want you to do right now. Yeah? I'm going to come back here to exercise 2.2. Here I have it. Here it is. Excellent. Yep. Then here you have some data. The odometry of the robot is published by the robot into the odom topic. Yeah, I have just shown to you this topic using the ROS topic list. Then you will need to figure out what message uses the odom topic and how the structure of this message is. Yep. So here you have some data, some hints. So now I'm going to give you 10 minutes. Let me see. It's here it's 19, 20 minutes. So I'm going to give you till 30 minutes. Yeah, 10 minutes is not much, so I understand if you don't do it, but at least you can start thinking a little bit how you would do it and try some things. So I'm going to wait here until for 10 minutes, more or less, so that you can try to do it by yourselves. Yes? Then let me come now real quick here to the chat and see what's going on. Let me check here some of the comments. All right. Alex Charters says, my Jupyter notebook is not loading. I have tried refreshing a few times. Now it loads. Still not working, and the simulation menu does not have any drop-down for selecting main launch. Okay, Alex, that looks like you have opened a wrong project, because you don't have anything there. So come here and open this project. Let me come here to the ROS.ds main page. So remember, all of you, you need to open Basic ROS Learning Week Day 4. Yes, this is the project you have to open. All of you, Basic ROS Learning Week Day 4, which is going to contain all of this, the notebook with whatever you did. Whatever you did during yesterday, yes? And at least it's going to contain all the simulation packages here in the simulation workspace. Yep. So let me keep checking here. I can see here, I don't have odom in the topic list. What is the reason? Well, the reason is that you haven't launched the simulation. It's the only reason I can think of. So you need to have the simulation running here, this simulation running. If you don't have the simulation running, if you don't start it, you are not going to be able to see the odom topic. Yes? So you need to have the gazebo simulation running. I can see here, hi, hello, Alberto. Suppose I have two launch files. We can use ROS launch. Topic publisher, launch 1, launch 2? No. Balaji Babu is asking, okay, that's sorry. That's an interesting question. So here, when we have, I have my package, topic subscriber, with my program here, simple topic subscriber.py, and my launch file, simple topic subscriber.launch, yeah? So he is asking, if I have another launch file here, so let's say launch file2.launch, yes? I have then simple topic subscriber.launch and launch file2.launch. So I have two launch files. Can I do like this? ROS launch of, let me source my workspace, source, catking workspace, devel, setup.bash. So can I do ROS launch topic subscriber then simple topic subscriber dot launch, which is the one I have for my program, and then another one. So for instance, launch file2 dot launch. So can I do this? No, you can't. So the ROS launch command, it's always as this, yeah? ROS launch, package name, and launch file. So you can only specify one launch file. Yes, with the ROS launch command. So you might ask then, okay, and then if I want to launch more than one launch file, what do I have to do? I have to execute one ROS launch command, then another one, then another one? No. Well, you can do that, but another thing you can do is to include a launch file inside another launch file. Yes? So inside this launch file, for instance, besides starting my program here with a no tag, I could do something like this. I could do an include, and then here I could include another launch file. Yes? Yes, so you could, here you would have to specify, of course, the path. Yes? Here, but inside the launch file, you can include another launch file. Yes, so that's how you would do it. But in the ROS launch command, you can only specify one launch file, like this. All right, good question, interesting. Let me check here more comments. Sandy Swear says, "How would love to have an extensive training of this if you can. So much to learn and all things looks new." Yeah, so ROS is huge. I mean, with this week we have barely scratched the surface, yeah, of ROS. So there are many more things to learn. So yeah, I don't know. Maybe during the following weeks we can repeat something like this. If you've liked this learning week. And you want to repeat, I don't know, let us know giving us support, and we might repeat another week of ROS training. Yeah, so let me keep reading here comments. I can see here, Avegang, you get the message type with ROS message show nav messages odometry. Yeah, that's right. You can use the ROS message show in order to get information of the message. Bill in Seattle says, I started the Dev Studio 15 minutes before the class and it loaded quickly, but was day 4, not day 5. When I loaded day 5, but I'm still waiting. I don't understand this message. So Bill, we are in day 4, not day 5. Yes? So you can say Basic ROS Learning Week day 4. We are all here working in day 4. Day 5, I haven't still shared the link for day 5. Yeah? So day 5 haven't still been shared. I will share it later. Yeah, so all of you have to be in day 4, not day 5. Forget about day 5. Yes, for the moment, we are in day 4. All right. Abekang, that's a good question. There is so much stuff in Odometry. What should we print? it's up to you. I don't know. You can print whatever you want. You can print the whole message or just the position of the robot, or yeah, I don't know. It's up to you. You can choose. I let you choose what to print from the message. Now when I complete the exercise, I'm going to see what I want to print. Alright, so we are already 10 minutes have passed. So let's go for it. So I'm going to start solving the exercise now myself. So, okay, the exercise is asking me to print the odometry information of the robot, yeah? So, what do I know? Here, the exercise is giving me some data. So what I know is that the odometry data is being printed, is being published, let's say, into the odom topic, yeah? So, I can come here, do a ROS topic list, and I can see here a topic which is named odom, yeah? So the first thing I'm going to do is to do a ROS topic info to get more information about this topic, yeah? So I'm going to do ROS topic info, odom. Let me minimize this. Then here, I can see that there is a node which is named gazebo, which is the simulation, which is publishing into this topic data. There is no subscriber, no one is subscribing to this topic, and the type of message that it uses is this one, odometry from the nav_messages ROS package, yes? So I already know that this topic uses the odometry message, yep? So let's start doing some things here in my program. So let me close all this now. First of all, here in the subscriber line, I'm going to modify the counter to subscribe to the odom topic. Yep, instead of counter, I want to subscribe to the odom topic now. Then, in the message here, I don't want, also my odom topic doesn't use integer messages. It uses odometry messages, yes? So I'm going to come here, get the message used by this topic, and paste it here into my subscriber configuration, yeah? So now I have that my subscriber is going to subscribe to the odom topic, and it's going to read odometry messages, yes? And then I have defined here my callback function, which can be named the same. This doesn't matter, yeah? Then, this odometry message, before being able to use it here, I need to import it, yes? Remember, always we are importing the messages we want to use in our program. But here we are importing the integer, not the odometry. So, instead of odometry, instead of integer, sorry, I want to import the odometry message. Yeah, here I have it. But the odometry message is not in the standard messages package, like I have here. But it is in the nav_messages package, yeah, which I have here, shown here. Then I'm going to copy this and put it here into my import line. I'm going to remove standard messages and place here nav messages. So now from the nav messages package, I'm importing the odometry message. Yes? So now, am I done? Let me know you. So if I execute the program like this, what would happen? Is it going to work? What it's missing here? What should I need to change here? Let me know in the comments, please. Yes? So, is this correct, this program? Or I need to do something else? Let me know here. I'm going to read you now in the comments. It's wrong, says Richard Boyce. Tuhit Ahmed says, nav messages don't have only data. Yeah, you are getting close. Alberto, need to change the callback function, says Mauricio Ferrari. Master says, check the message type of odometry. It is not data. Okay, yeah, very well, very well. I see that you are on point, and all of you are right. Yes. So here I was printing the data value. Why? I was proving this data variable because the int message, which I'm going to check here. Yes, so the int message, which is the one I was subscribing to before, it had this data variable inside. But the odometry message, it's not as simple. So it has many more fields inside. Let me have a look here with the ROS message show to the odometry message. So as you can see, here doing the ROS message show of the odometry, I can see what this message has inside. And as you can see, it's a huge message. So it's a quite complex message. It contains many other messages inside. Yeah, so it's a complex message. It contains a header. It contains information about the pose of the robot here. It contains information about the velocities here, about the twists. And also it has some covariances. Yep. So, for instance, one thing I could do here is to remove the data field. For my program, I'm going to remove the data field. So this, what is going to do? This is going to get the full odometry message here, and I'm going to print the full odometry message, yes? So I'm going to print everything, all this, all the contents of this message, I'm going to publish them all, yes? Because I'm getting the whole message here. So I'm going to try now this. Let me come here and do a ROS launch of my package topic publisher. Well, I don't know if I removed, yeah, okay, I have it right. So ROS launch, I don't know what I did here. I hide it. Let me refresh this because I hide it here. Here I have my list. All right. So ROS launch topic subscriber is the name of the package and the name of the launch file, which is simple topic subscriber. So now, if I do this, if I execute this, I'm going to start getting here the whole odometry message, yeah? Let me stop here because this is a lot of information. So as you can see here, I have all the message, yes? Let me show it better here. So I have all, the header, the pose, the twists, yes? I have everything now because I am getting all the message variable, yes? So what now if I want to only print, I don't know, I'm going to only print the pose information, yes? What should I do? Well, if I only want to print the pose information, I'm going to need to access this field here, yes? It's very important when checking messages structure, the indentation, yes? So from message, you are going to be able to directly access the ones which are more to the left. So for instance, header, frame ID, pose, twist, yes? So this is the first level, let's say. So if I want to print, for instance, the pose, I'm going to need to do here message dot pose. Yes? So I'm going to save and I'm going to run again my program. And now I'm going to only get the pose information. Yes? Let me stop it. So as you can see now, we are only seeing the pose information. Pose, 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 pose. We are not getting the header or the twists, yes? So what if now I want to only print the position X, yes? So inside pose, I would need to access pose, yes? Because this message is inside the first pose. So from the first pose, I would access this second pose. So I would put here message.pose.pose. Now what? Now I need to access the next message, which is position. So pose, position, and finally I can reach the X, which is inside this position message, yes? Then finally I can reach the X. Yep. So now I'm only going to print the position in the X axis of the robot, yeah? So let me run one more time my program. And now, as you can see, we are only getting the X position, which is 0.0, because my robot is at the 0 position, yeah? I haven't moved it yet. Yes? Alright. So, we have created a subscriber for the odometry topic, yes? Okay, let me have a look at the chat and see if we have some questions here. I can see here Richard Boy says print, message, pose, position, X. Yep, that's right. That's right, great. The odometry message carries more than one data. Yep, exactly. Afif, it contains many data. It contains data about the position of the robot, orientation of the robot, velocities, etc. Alright, Hao Liu is saying, I only find this topic, nav messages odometry, instead of odom. Is that the same? No. The nav messages odometry is the message. The /odom is the topic. I can see that my colleagues have already answered to you that. So, let me keep going down. Can you explain about the indentation of message? Marco Antonio is asking. Yeah, I have just explained it. I don't know if that was before I did the explanation. Yeah, but the indentation of the message, let me repeat it really quick. The indentation of the message indicates the different levels. Yeah, so the first we have the general message, the wall message, which is odometry, and inside this message we have different messages. So first we have the header message, which at the same time contains inside the sec, the stamp, and the frame ID. Then we have another child frame ID here, which is at the same level as the header. Then at the same level we have the pose message, which contains inside another pose, which contains inside a position, which contains inside 3 floats. Yes? And etc. So basically this indentation indicates the different levels. So for instance, from the main message, from the full odometry message, I cannot access this variable directly. I cannot do message.sec here. I cannot access this because it's not in the same level, yeah? So first I need to enter the header message in order to access this sec. So I will need to do message.header.sec. Yep. Let me keep checking some messages here. Thanks, Alberto. Okay, I can see here another question from Mauricio Ferrari. Alberto, always I need to put message in the import. If you are importing a message, yes. So he's talking about this in the import. Here, if you are importing a message, yes, you always need to add this dot message. And what is this? Let me show you real quick what this dot message means. So this is a ROS package. This is the ROS package that contains the odometry message. And this odometry message is defined inside this ROS package, but inside a folder which is named message. Let me show you to you. So I'm going to come to this nav messages package using the ROS CD command, ROS CD nav messages. Yes, so now I am in the nav messages package. Here, if I do an ls, I can see a folder which is named message, MSG, yes? So if I enter this folder, cd msg, and I do another ls, here I can see many messages being defined. One of them is the odometry.msg, yes? This is the file. You can visualize this file, for instance, here with a cat command, I don't know. And you can see the contents, yes, of this, how this message is defined, yes? But this dot message basically defines the folder where this message is defined, yeah? So you can see here, nav message and the folder message. So that's why you always need to specify this dot message here in the import. Good question, Mauricio. All right, so I don't know what opened here. Let me close it. All right, so I think I'm going to keep going. Okay, so let's keep going. Let's keep moving. All right, so let's move to exercise 2.3. Yeah, so here it is asking us to, let me make it bigger. Okay, add to exercise 2.2 a Python file that creates a publisher that indicates the age of the robot. For that, you'll need to create a new message called age.message. To see how you can do that, have a look at the detailed description. Yeah? So, basically we are going to create a publisher which is going to publish a custom message that we are going to create right now. Yes? And then we are going to modify our subscriber to subscribe to this message. Yes? But let's go by parts. So first of all, we are going to create our custom message. So in order to create a new message, we need to follow always the next steps. First, we need to create a MSG directory inside our package, yeah? So this is going to be the first step. We need to create a new folder named MSG, which is going to contain the message files. Then, inside this folder, we are going to create a file with the extension .msg, yeah, .message. Then we are going to need to do some modifications to the semaglist.txt file of the package. Yes, this file. We are going to need to do some modifications in order to be able to compile our new message. And also, we are going to need to do some modifications in the package XML file. Yep. And then finally, we are going to need to compile our package. Yes, so this is mandatory, because we need to compile the package in order to generate this new message so that it can be used. And finally, we are going to be able to use it in our code, yes? Then, I'm going to create with you the message step by step, and later I'm going to let you finish this exercise once we all have this message created, yes? So first thing is to create this MSG directory inside our package, yes? We can do this like it explains here through the web shell, or we can create it through the IDE. So I can come here to my, let me do it here in the, whoop. In fact, I'm going to create a new package, okay? So I'm going to create a new package here, which I'm going to name Catkin create package new message. Yes, so I'm going to place here, where is my shell? I'm going to create my package here, new message, yes, and I'm going to add ROSPy as dependency. Yep. Or no. Let's do it directly in the topic publisher package, okay? Let's do it here in the topic publisher package. Better, because if not, you're going to need to create another package and maybe it's too much. We're going to lose too much time. So let's do it here in the topic publisher package. So here, let's create a new folder. New folder. I'm going to name this folder MSG. Yes? Now, inside this folder, I'm going to create a new file, which I'm going to name h.msg. Yes? So inside this MSG folder, I'm going to create a new file named h.msg. And I'm going to put these contents into this message file. I'm going to copy them from the notebook and paste them here to my message file. So basically, my message is going to contain 3 floats inside, yeah? One to specify the years, another one to specify months, and another one to specify days, yes? So inside my package, I create the message folder, and inside I create my message file, which is named h.message, with these contents inside. Yep. So now I have created my message file. Then, now I need to compile it in order to generate this message. But before that, I'm going to need to do some modifications in the semiglists.txt file. Yes? Basically, I'm going to need to modify some things here in these functions. Yes? So let's go by parts, because semiglists.txt file, it's a very it's a complex file, let's say. It's CMake, and it's not easy to understand, and if you don't do this carefully, you're going to break your package, yeah? So you have to be super careful when you edit this semiglists file, yes? Super careful. So pay a lot of attention to what I am going to do right now, yes? So, first of all, let me make this bigger. At the top of the semiglist file, you're going to see this find package function, yes? Which now only contains ROSPy, yes? So basically, this is defining the dependencies of my package, yes? Which other packages my package needs, yes? Remember that when we created these packages, we were specifying always the ROSPy dependency, so that's why we have it here. But now we are going to manually add more dependencies. One, it's going to be, so here I'm going to press enter, and below ROSPy I'm going to add the standard messages package, yes? Standard underscore messages. And I'm going to add another one, which is going to be message underscore generation. I have it here. My ID is auto-completing it for me. Yeah. So inside the find package function here at the top of the semilist file, I'm going to have ROSPy, standard messages, and message generation, just as the notebook shows. Yes. Here you have it in the notebook. Yes. So you need to do this in your semiglists.txt file. Yep. Then next we are going to find this. Well, let me wait a second and see how you are doing, guys. Okay. So are you following, guys? I can see here my colleagues are answering some questions. Are you following me? Okay, Mauricio Ferrari asked, Alberto, why we need the standard messages? Okay, we need the standard messages because in our message we are using the float 32, which is a type defined in the standard messages package. Yes? That's why. Because inside our message we are using float 32 messages. This message is defined in the standard messages package. So that's why I am importing the standard messages. Yep. If, for instance, inside my message I put another variable which is odometry, which could happen, yes, odometry whatever, then I would need to add as well the nav messages, yes? But since we are only using floats, I have to add the standard messages, which is the package that contains the floats definition. Yeah, that's why. Yes, following, yes, yep, okay, yes. Okay, yes, Alberto. Okay, excellent. So let's keep going. I can see that you are following. So we have modified the find package, and next thing, we need to come here a little bit down and find this function which is commented at message files. Yes, a trick you can do here is to press Ctrl F, for instance, or Command F if you are in a Mac. Yeah, here. If not, if you don't want to use the shortcut, you can come here. Let me try to find it. Selection, its file. Let me try to view here. Find. I cannot find here where it is. The find command. However, it is usually it's going to be Ctrl F, yes, in your computers. So this is going to open here a small text box, input box, where you can find you can put anything, any character, and it's going to find it in the file. So for instance, you can put here at message files, and if you hit enter, it's going to take you to this function. Yeah, the function is at message files. You are going to find it here commented. Yeah, it's in green because it's commented. You can see here at the top it says generate messages in the MSG folder. Yeah, so now we are going to come here and uncomment this. We are going to uncomment it, uncomment it, and uncomment it. Yes, we are going to leave the message to commented because we only need one message. Yes, we only have one message. Or you can remove it if you want as well, yes? So you can come here and remove it. But basically you need to have this at message files uncommented. And then, what else do we need to do here? Well, we need to put the name of our file, because our file is not named message1.message. It is named h.message. Yes? So you are going to have your function like this, with the h.message. Inside, yes, you have it also here in the notebook. Yep, you have it here. You can check it here, how you should have it like. Yep. All right, let's keep going. Let's go to the third modification. Now we need to find this generate messages function. Yes, so I'm going to come here and find this generate messages function. Here I have it. So here, again, it's a little bit below these at message files, yeah? So you can see that it's very close to it. Here you have the generate messages, and here I'm going to uncomment everything, yes? So I'm going to uncomment the whole function. First line, second line, third line, and fourth line. So I'm going to uncomment everything, this generate messages function. Yes, so I have it like this, like it is shown here in the notebook, yes? With the generate messages, dependencies, standard messages, yes? Then finally, we need to find this catkin package function. Yes, so let me come here and find this catkin package function. Here I have it. Yes, so in this catkin package function, we can see that it is already uncommented, the first line and the last one, but all the contents which are inside this function are commented. Yes, so here we are going to uncomment, as you can see here from the notebook, the catkin depends line. So here you're going to see that you have 4 lines. One that says include dirs, another one it says libraries, the third one it says catkin depends, and the last one says depends. So we are going to uncomment the third one, the one that says catkin depends ROSPy, yeah? So I'm going to uncomment this one, there I go, it's going to turn white, and I'm going to have catkin depends ROSPy, but at the end I'm going to add another dependency here, which is going to be message runtime. I think it's runtime or generation, I don't remember very well now. It's message runtime. Yes? you have it exactly here. Catkin package with catkin depends and ROSPy and message runtime as dependencies. Yep. So far so good. Okay, and now save the file, yeah? Pay a lot of attention, I'm telling you now, pay a lot of attention to the modifications you have in this file, yes? To what I have done, and check very well how it is shown here in the notebook, in the different sections, in the catkin package, generate messages, add message files, and find package, yeah? Pay a lot of attention to this, make sure that you have it like this, because otherwise you're going to get errors in compilation. Yeah, it's very easy to get errors on compilation when modifying this semi-glitch file. Yes? So let me see if all of you are following until now. We have finished the more delicate part. Now it's going to get easier with the package XML. So let me have a look here at the comments. So let me know, guys. Let me know here. Okay, following. All good until now. Let me know. Are you understanding everything? Do you have any questions? I can see yes, yes. Yes, all good. Nuria Pujol asks, what's the message? What's the meaning of adding message runtime as dependency? Very good question, Nuria. I'm going to answer it in a moment, okay? Now, I'm going to answer this question about the message runtime. Why this dependency? Nauman is asking, but why are you are modifying all this? Because I need to modify this in order to be able to compile the package, yes? So, let me modify very quickly the package XML file, and maybe you are going to understand this better, yes? So, here, if you go a little bit down in the notebook, the next thing is to modify the package XML, yeah? Super easy. You have here 3 lines, which you are going to come here, copy and paste, yes? Here the build depend message generation and build export depend message runtime and exec depend message runtime, yeah? So grab these 3 lines, copy them, open your package XML file and paste them here. Yes, here you have all the dependencies, the ROSPy dependencies. So I'm going to come down here and paste, and let me put this right, because they have lost their indentation. There we go, and there we go. Yes? So I have copied from the notebook these dependencies, message generation, message runtime, and message runtime, yeah? So, why I need these dependencies? Well, I need the message generation, I need it in order to be able to create a new message on compilation, yes? So, okay, I'm getting this message, don't know why. I'm going to just ignore it. Okay, so this message generation package is going to allow me to, from this file, compile it and create a new ROS message. Yes, that's why the package is called message generation. So basically this package allows you to generate new messages. Yes, which is exactly what we are doing now. And message runtime allows you to use these messages. Yes? So once you have generated the new message, this H message that we are going to generate right now, in order to be able to use it, to run it, we need to also add this message runtime package, yes? Then, because I am adding these dependencies here in the package XML, I need to also add these dependencies here, yes? I need to add the message runtime here, and the message generation here. Yes? Because the message generation, as you can see, there's a small, okay, these are a little bit complex topics, but as you can see, we have the message generation as build depend only. This is because we only need this when we compile this package. Yes, because when we compile this package, it's when the message is going to be generated. Yes? Then, as an export and as an execution dependency, we need the runtime, not the message generation. Yeah? So once we build and compile our package, then in order to be able to export it or use it, we need this message runtime package as dependency. Yes? And that's why here I'm importing the message generation here, because it's for the compilation, and the message runtime here. Yes, here down in the Catkin package. And also I am commenting this because basically this is what this is telling the system that in compilation I want to generate a new message, and I need to specify here the new message I want to generate. Yes, here I have the name of my file, of my hmessage file. Yep. So now I'm going to be able to compile, and when I compile, I'm going to be able to generate this message. So now, for instance, if I do a ROS message show of the topic publisher age message, okay, I already have it here because I have it installed in the system. I think it is why. Yes, but anyways, let's come here to the Catkin workspace and let's, okay, yeah, let me check one thing very quickly. Okay, it's detecting it, but for some reason, but I am not going to be able to use it yet. So let's compile and let's build it, and you're going to see how it is created. So let me compile here my Catkin workspace. Okay, this is compiling. Remember, for compiling, you need to be on the Catkin workspace folder, yes? Otherwise, you are going to get an error. So you need to be here. You need to be in this folder, yes? In Catkin workspace, in order to compile using the catkin_make command, yes? Then you can see here in the output that it's basically calling here some dependencies in order to generate the messages, as you can see, and then here it started to generate JavaScript code, generating C++ code, generating Python code for this message, for the message topic publisher age. Yes? So it's basically compiling and generating all the files and everything it needs in order to build this message so that we can use it now in our ROS programs. Yes? So once it finishes, you can see here that it has finished compiling. We are in the 100%. So when it finishes compiling, we are going to source our workspace like this. Source devel setup.bash. Yes, so let me come here to my shell and execute this command, source devel setup.bash. Yes, so have you all been able to compile this properly? Did you did you get any error on compilation, or did you compile successfully like me, 100%? Let me know, please. Master says error while compiling. It says invoking CMake failed. Okay, make sure that you are doing the catkin make from the catkin workspace folder. Yes, and not from another place. Master, check that, please. I can see mine worked, 100% success. Compiled, okay, 100%. Okay. Okay, I can see, I think it's Ricardo, who is saying, Alberto, mention about the coupon with 15% discount at Academy. Coupon shared in your Slack. Okay, let me check this real quick. Okay, so as you can see, we are communicating here through, okay, I have seen the coupon. So I suppose, Ricardo, that you want me to share it here in the YouTube channel, and let me know, please, here in the comments. I'm reading you. Okay, so I can see here, looks like it worked. Engineering Nation, compiling. 100% success, worked, 57%. I get this error invoking make the make check build system failed. Okay, then if you get an error and you are doing it from this folder, from the home user catkin workspace folder, you are doing the catkin make from here, then it's an error in your CMake list file for sure here. So review your cmakelist.txt file, review it, and make sure that everything I have done, you have it the same, yes? Go, you have all the steps here in the notebook, here, yes? And review these steps, review all the functions that you have them the same way, check that you have also the closing parentheses uncommented, yeah? You can check and compare with the notebook. So, because that errors probably are because you have done something wrong here in your cmakelist.txt file. Yep. Let me come here real quick. Okay, so yeah, I can see that my colleague Ricardo here is explaining to you to that for it's telling you about our academy, etc. I have already told you a lot about the academy. So basically now I'm going to paste here in the channel a discount coupon, which is going to be valid until the April the 3rd. Yes, so for 1 week. I think this is April the 3rd, it's next week. Yeah, it's a 15% discount on our academy. Yes, in case you want to keep learning more on this, building more on this, learning more advanced topics like ROS services, etc. So there is many more to learn in ROS. I'm going to share here in the channel here a discount coupon. Yep. So if you subscribe to our academy using this coupon, you are going to get a 15% discount. Okay. So there it goes. Let me keep reading here the successful 100%. Okay, 100%. Excellent. So I can see that most of you are having success with this. Excellent. Okay, so we already have our message built. Yes? So now what should we do? Okay, so let's use it, right? Let's use it in a program. Then here in my I'm going to open my publisher, my topic publisher package, src folder, my Python file, And here I'm going to use and publish my message, yes? And I'm going to do so like this. So, first of all, I need to import my message, right? So here, I'm going to import my age message, yes? And where is this message from? From which package? It's from the topic publisher package, yes? So from the topic publisher package, yes? From topic publisher, the message folder, here we have it, import the age message, yes? Then the init node, I'm going to keep it like this. The publisher, I cannot publish this message into the command bell topic because the command bell topic uses the twist message, yes? So I cannot message here, I cannot publish into this topic age messages. So for this new message, I'm going to create a new topic. I'm going to name it age_topic, for instance, yes? And in this topic, I'm going to publish messages of the type age, yes? You can put another name if you want, I don't know. I'm naming it age topic, yes? So now here, in this line, I am creating a publisher which will publish into a topic named age topic and will publish messages of the type age. Yep. Then I need to generate here my new message because I'm not using twist anymore. So here I'm going to create a new message named age, which is going to be which is going to be of the type age that I am importing up here. And the fields, I'm going to fill now these fields, the fields of this message. The fields of this message are, I have them here, years, months, and days, which are floats, yes? So, here I'm going to put age.years. And also, I will add here age.months and age.days, so that I can put values now to all the fields inside my message. Then I'm going to say that age, I don't know, I'm going to put here my age, for instance, which is 30 years. Months, I was born on January, so it's 1, 2, 3 months. No, actually it's 2 months, and I was born on the 4th of January, and we are today in 27, so I am 30 years, 2 months, and 23 days old. Yes? So I'm going to put this like this. Yeah, I'm going to fill my message with the data of how old I am. Yes? Yes, I know I'm almost a dinosaur, but well, it's what it is. I cannot do nothing about it. All right. So yeah. So now what I'm going to do is to publish my message. So I need to publish my age message, the one I have generated here, and fill it with data here. Yes, and then the sleep, in order to control the rate of my while loop. Yes. So now I'm going to run my program. So ROS launch, topic, let me here source again, and ROS launch topic publisher simple topic publisher dot launch. So I'm going to run my publisher right now. There we go. Here it's running. So now what will happen? Well, now I'm going to come here to another shell and I'm going to do a ROS topic list. And what happens? It happens that if I come here to the top of the list, I'm going to see that there is a new message here appearing here. Yes? And the name of this topic, the name of this new topic, it's age topic, which happens to be the topic that I am creating here in my program. Yes? So now, if I do here a ROS topic echo of this topic in order to see the contents, ROS topic echo. Well, in fact, yeah, I'm going to do an echo, and later I'm going to do it with the subscriber. So ROS topic echo of the age topic. Now, here I can see the messages that are being published into this topic, which are 30 years, 2 months, and 23 days. Yes? So this, the same, exactly the same, I can do it in the subscriber. So now in my subscriber, I'm going to modify it to subscribe to by age message. So I'm going to import the age message from the topic publisher package. Here I'm going to subscribe to the age topic which uses age messages, and in the print I'm going to print the whole message. Yes, so now here, instead of doing the echo, I'm going to run ROS launch topic subscriber and simple topic subscriber, which I'm going to be able to visualize as well these messages. Yes, I can see here the 30 years, 2 months, and 23 days. Yes? Okay, excellent. So far, so good. So let me have a look at the comments now. So let me tell you that with this, we have finished this project, yeah? So we have finished this theory. And, well, we have here a small exercise at the end, but we are going actually to do this exercise in the... I'm going to move this topics project we have here to the robotic challenge. So we are going to start doing it there. Yes? So we have finished here the theory. Excellent. Excellent. Yes? So let me have a quick look here at the chat and how you guys are doing. Let me check here. Yay. Alright, finished the publisher. I can see here a message from Marcus. I recommend all of you to be inside the academy. It is an amazing journey. Thank you very much, Marcus. Yeah, I also recommend to all of you to get inside our academy. Okay. I can see an error. Lalit Gupta. Invalid ROS launch XML syntax. So this is an error in your launch file, Lalit. Here, review your launch file. Yes. Review here your launch file, that all the fields are correct, the package of the name, the package of the program, the name of the program, of the node. Review that your launch file is it's okay, yes? Because that the error you are showing there, it's an error in the launch file. So review your launch file, please. Master is asking, can you display your publisher.py file? Yes, let me show it here. My publisher, it's like this. Here I have it. All right. It's telling me that the topic is not yet published. Well, then that's because you are not publishing it. So you need to launch your publisher, to create your publisher and launch it, so that it starts publishing messages into the topic. Nuria Pujol is asking, there is any course related to ROS 2? Yes, there is, Nuria. We have a course for ROS 2, ROS 2 Basics. All right, excellent. So Balaji Babu. Okay, I can see more questions here. Balaji Babu. Hi Alberto, we need to compile after changing code? No, it's not necessary to compile. Balaji. Because it's not necessary to compile because you are just modifying a Python script. And Python scripts don't need to be compiled, yes? But it is mandatory to compile in order to generate the message, yes? So if you compile, generate the message, and have the message generated, and later you just modify the Python script, then you don't need to compile again, yes? Because you are just modifying a Python script. If this was a C++ script, for instance, then you would need to compile also, yeah? But if you work with Python, it is only mandatory to compile when you create a message. Otherwise, it's not necessary to compile. All right. Madame Sol is asking, we will not see day 5 content today, aren't we? We are going to see it, and we are going to see it right now. So, right now, let me share with you the day 3, where I have it. Let's come here. I'm going to share with all of you now the project for day 5. Let me grab it here and paste it. There we go. So now in the chat, all of you, I'm going to post it a couple of times. 3 times. So all of you, you have there the link to the project of day 5. I'm going to grab it right now. So I'm going to get out of here. Let me stop everything I have running. Very quick. Let me close everything. Have many things open here. So let me come here, close all the shells and everything. All right, let me close this. I'm going to close the shell as well. The IDE, the gazebo simulation, I'm going to save, very important, I'm going to save to conserve all my files. Everything I have created, I'm going to save it so that I don't lose it. Here it's indicating me that it's saving until it shows the green tick. You can see it here. So now it's saving now. Now it has finished saving. So now I'm going to close and I'm going to paste here the link for day 5. Let me get out here. And I'm going to paste the link for day 5 right here, which is going to show me my project for day 5. Let's go. And here I have it, yeah? So, Basic ROS Learning Week, day 5. Then, when you have this project in your workspace, come here and open it, yes? So, Basic ROS Learning Week, day 5. Let's come here and open this project. Okay, it's opened super fast. Here I have it opening. So all of you get the link and open your project for day 5. All of you. Let me go to the comments and see how you are doing. Loaded, says Richard Boyce. Whoops, sorry for impatience. Don't worry, madam, don't worry. Yeah, loaded. Loaded, awesome, saying Abe Kang. Yeah, awesome. We are going to have time to have a look here. So the good thing is that for this project there is not much to explain. I mean, all the theory we have already explained in the previous days, and today I'm going to just present to you a robotic challenge. Yeah, I'm going to present you a problem, a robotic problem that you are going to need to solve by yourselves with your knowledge. Yes, I'm going to explain you some things here, give you some hints and how to start, but then you're going to solve it. You're going to have to solve it by yourselves. Yes, so I'm just going to introduce you to the challenge. All right, so let me have a look here at the comments. Loaded and ready to go. I can see here Balaji Babu says, "Hi Alberto, deep learning with ROS. Please conduct the course like that. We will pay the course fee." Well, Balaji, let me tell you that we already have deep learning courses in our academy. So, if you are interested in that, you can come here to the academy. Let me show you real quick. This. I already have here my project, which I am going to show right now. But here, if you come here to the courses section, ROS courses, here you are going to see all the courses we have in the academy. We have here ROS Basics in 5 days, ROS Basics in 5 days, but in C++ instead of Python. So if you are interested in doing it with C++, here we have a mastering mobile manipulators, which is a premium course. It's super good course, this one. Here we have the ROS2 course, which also someone was asking there. ROS2 course, we also have it. Free courses. Here we have a course of working with NVIDIA Jetson Nano. Yes, this is for deep learning. Doing deep learning with NVIDIA Jetson Nano. Deep learning with domain randomization. OpenAI. Also deep learning with OpenAI. Deep learning with TensorFlow. So we have many courses here. Yes, as you can see, you can come and have a look. And you can use the discount that I have shared in order to get a 15% discount on the subscription, yeah? So as you can see, we have many courses here, ROS navigation, etc. So let me close this, and let me go back to the comments one last time. And then I'm going to explain the challenge to all of you. So let me have a quick look here at the loaded. Okay, loaded. Okay, excellent. Okay, excellent. So it seems that everybody is prepared. So let's go with the challenge. Yep, let's go. So everybody has the project loaded, as always. And here we have the notebook for day 5. Yes, the ROS Robotic Challenge. Then let's move directly to set up the environment here. So let's set up the environment. As always, we are going to come here to the simulations menu, choose launch file, and in this case, we need to choose the turtlebot project.launch file. Yes, so from the simulations menu, I'm going to click here and choose launch file. I'm going to look for the turtlebot gazebo. Here I have it, and then here I'm going to select the turtlebot_project.launch and click on the launch button. This is going to start the gazebo simulation that you can see here in the notebook, in the image. Let me put this in small. And here, let me move the simulation to the right. Here I have my simulation loaded with the turtlebot robot, which happens to be here inside a maze. Yes, as you can see here, we have the turtlebot robot inside a maze. Then this maze has an exit, as you can see here, an opening. Yes, so basically the challenge is going to be to make the robot using ROS and using its sensor data, yes, come autonomously. So you are going to run a program and the robot by itself is going to be able to go all the way until it finds and it exits this maze. Yes? So this is going to be the robotic challenge that I'm going to present to you right now. Yes? Are you scared? Are you confident? Do you think you are going to be able to do it? Yes? I hope so. Okay, so basically some things here to introduce you. So, as I've said, basically this is the thing that you are going to achieve with this challenge. Then, yeah, so basically apply all of the theory given in the basic ROS Learning week. So you are going to need to apply especially everything you've learned from Python and basic ROS, ROS publishers, ROS subscribers, messages, how to read from messages, the site depending on what data you have, yeah. Then implement a strategy and make as many tests as required in the simulation environment until it works. Yeah, so you are going to be able to test as many as you want. Then, some things to remember. You can create your packages and code in the simulation environment as you have been doing throughout the week. So this is the same environment. You have the IDE here with the Catkin workspace, which in this case it's empty because you don't have yet nothing here. So you are going to be able to create your packages here with the shell, Catkin create package command, remember? Yeah, so you already know all this. Use the consoles to gather information about the status of the simulated robot. Yes, so you can open shells here in order to execute your commands, ROS topic lists, whatever you need to do. Use the IDE to create your programs and execute them through the consoles, observing the results on the simulation screen. Then everything that you create in this project will be automatically saved in your space. So it is very likely that you are not going to complete this in one day. So you can start working today until you want to finish. Then when you finish, you save your project, you close the studio, and you can come back and open your project tomorrow, next week, whenever you want, and keep working from the point you left. Yes? Then every time you need to reset the position of the robot, you can use the following command. So it is very likely that doing tests, you are going to make the robot crash or whatever. So for instance, I'm going to right now move the robot so until it crashes with the wall. So let me do that right now. Yeah, so I am moving my robot forward and it's going to crash there with the wall. There you have it. Now I'm going to stop it. Yes. So while doing your tests and while creating your programs and testing your programs, things like this are going to happen. Yes. Then, in order to reset the robot and bring it back to its original position, you can use this command. Yes. Then you can come here, copy the command, come to the shell, execute the command here in your shell, and the robot is going to go back, as you have seen, to its original position. Yes? Very important also, because for testing this is super important. Then, final note here. Because the program that you create, so you cannot create a program which is a closed loop. Yes? You need to make the robot exit the maze by being intelligent, let's say, by using a kind of artificial intelligence, yes? So you cannot make the robot exit the maze by saying, okay, move forward 3 seconds, then stop and turn to the right, move forward 4 seconds, then stop and turn to the right, move forward whatever, and then turn. No. You cannot do that, because then, if you do a program like that, then, for instance, if we put the robot in another position, here, for instance, it's not going to work anymore, the program, yes? So we need a program that works always, yes? So we need a program that makes the robot start moving forward, then if it detects a wall or something in front which is going to crash, it stops, then it checks the laser, it decides if he needs to turn to the left or to the right, depending on the laser readings, etc., etc., yes? So the robot needs to be kind of intelligent, yes? Alright, so far so good. Let me check the comments area. Let me know, guys. It's like autonomous driving. Yeah, well, autonomous driving, it's quite more complex than this, but it's kind of, yes, we are going to do a kind of autonomous driving. Yeah, so the robot is going to autonomously drive. I love the project, is saying Master. Okay, I love that you love the project. Yeah. All right. Then some more information. I'm going to keep going. Let me know, please, here in the chat, if you are following the project, everything I am explaining. Then, what does Turtlebot provide to program it? Basically, it provides 2 sensors and 1 actuator. Yeah. So the sensors are a laser sensor and an odometry sensor. Yes. So here in the laser you can see that this laser publishes into the Kabuki laser scan topic. Yes. So if we do here a ROS topic list, we are going to see this Kabuki laser scan topic. Yes, this is the topic where the laser is publishing its data. Yes, and the odometry, as we have already seen, it's being published in the odom topic. Yep. Then as actuators, we have the speed movement. Yes, the wheels. Then in order to move the robot, you already know this also, you need to send commands to the command belt topic. Yes, you already knew this. You already know about the odometry topic. And the newest one is the Kabuki laser scan, which I'm going to explain you a little bit more right now. Yes? Then here we have some, in order to finish the notebook, we have some ideas to start working on. So, first, start watching some of the messages that the sensor topics are publishing. Try to get an idea about the information they are providing. Move the robot in the simulation and see how those messages change their values. It is very important that you understand how changes in the robot produce changes in the topics. Yes, super important. So, how the robot movement affects the sensor data. Then try to move the robot sending messages to command belt. Move it around and see what happens. See what happens with the sensors, of course. Then observe how the messages of the topics change when the robot moves around the environment. Yep, so some ideas here to start working on. Then, we know how to move the robot using the command belt topic. Yeah, I have just done it. You know, it uses twist messages. You already know how to do that. Yes? We know how to read information from the odometry data. Also, yes, we have done an exercise just a few moments ago about that, reading information from the odometry data. Then, we know the structure of the odometry data as well, yes? So we just checked it before. And basically, let me tell you that from the odometry data, you are just going to need the position in X, Y, Z, and maybe the orientation if you want to use. Yes. So the only message that really you are going to need to use, it's the pose. Yes. Pose, understand as position and orientation of the robot. In which position in this world the robot is. In which orientation is. Yes. So this is the only information you actually can use from here, because the header, for you, it doesn't matter, and the twist, well, you could use it as well if you want, but I think it's a little bit more advanced. Yes, so just focus on the pose. Yes. Then, what else I want to explain to you? I want to explain to you about the laser. Yes, about the data in the laser. So let me show it here. Well, first of all, let me do a ROS topic info of the Kabuki laser scan to get information. So first thing I can see here is that this topic uses this type of message, sensor messages, laser scan. Yes. So let me check about this message. ROS message show laser scan. So all of this is what you should do. Yes. Start investigating. Start seeing. Yes. Things here, but I am helping you to start because it's normal. So I'm going to check information about this laser scan topic. I can see that it has a header and it has some data here. It has angle minimum and angle maximum, which basically is information about the maximum angle of the laser, how much it covers. In this case, remember that the laser mounted in the Kabuki robot, it covers an area of 180 degrees. Yes? So in front of the robot, it covers an area of 180 degrees. Then we have the minimum and maximum range of the laser, which we are going to see right now, and the ranges array. This is the most important part of the message. So let me see a message of this topic. ROS topic echo, Kabuki, laser scan minus N1, because I only want to see one message. So let me come back to the top of the message here. This is only one message, remember. So I can see that the angle minimum is minus 1.5 and the angle maximum is 1.57. So this is basically, this is as you can see, this is the half of 3.14. Yes, so this is half pi. Yes, this is minus half pi and this is half pi. So this basically means, if you know about the pi number, this basically means that it goes from, well, basically it covers 180 degrees. Yes, it's a semicircle, let's say, covering 180 degrees in front of the robot. Yep. Then you can see that the maximum range of the laser is 30 meters also. And then what is this? What is this? In fact, let me do one thing in order to explain this better. I should have placed it here in the, but I don't have it, so I am going to show it from the Ignite Academy very quickly. You don't need to do this. Don't worry. I'm going to do it so that I can explain better this really quick. All right, this is loading. Let me go to the comments and see how you guys are doing. Okay, great. Okay, Mauricio says, sorry guys, need to go now, but I will finish the class after and try to solve the project. Thanks in advance, Alberto. You're welcome, Mauricio. Okay, so yeah, take care and try to do it later. Is it possible to turn the robot by 90 degrees? Which is the correct velocity time combination? Yes, it's possible to do that, Marta Gandoya. But there is not a velocity time combination. Well, yeah, you can do it by moving velocity in a certain amount of time, but that's not the recommended way. So you should try to do it by checking feedback on the odometry. Yes, you can check in our channel. In our channel, we have a video exactly explaining about this. So have a look at it if you want, in order to how to make the robot turn a certain amount of degrees using feedback from the odometry. Yes, we have posts and videos explaining it, so you can get information from there. I can see that the constructor is already answering that to you. All right, so I have this loaded. Let me come real quick to where I want to go, which is to Linux Essentials. It is, I believe. I think so, yeah. Okay, so what I wanted to explain here, because here I have it in a graphical way, which is much more clearer. No, it's not here. Okay, I see. It's not in the Linux, but it is in the Python course. Okay, give me 1 second to open the Python course. All right. There we go. In which reference frames the odometry gives the position? Very good question. Very good question, Fabio. So, you can know that by yourself. So if you have a look here at the, if you have here, in the project, if you have a look at the odometry message, using the ROS message show, so all the information you want, you can get it yourselves using the message, the commands that you already know, yeah? So let me tell you this. All the information that you want, you can get it from commands. If you check the odometry message, you are going to see here some parameters which talk about frames. Frame ID, child frame ID. Yes? So, if you do an echo to the odometry topic, to the ODOM topic, in order to check one message, only one message, you're going to see here the frames. Yes? So the frame in this case, it's ODOM, which is child to base footprint. So basically the frame is base footprint. Yes? Could you please mention some important coding algorithms for robotics? I don't understand your question, Aman. Can you try to rephrase it? I don't know what you mean by coding algorithms. Marco Antonio is asking, the classes will be available for this week to practice more about ROS? Yes, they will be available forever in our YouTube channel. So we are going to upload, we have already uploaded all the previous days, and today's class we are going to upload it as well. Okay, so all of you, pay attention right now, yeah? All of you, I want your attention, one moment, because this is very important. So, let's come here, Python Essential. So, I'm going to explain how to interpret the laser message, the laser data from the simulation, yes? So let me get one more time one message from the Kabuki laser scan topic to analyze it, yes? So we have already seen some data like the angle it covers, the range, but we need to understand this ranges array. What are all these numbers here? There are a lot of numbers. What is this? What do they mean? So here, I'm going to use here a picture to explain it to you. So, as we already explained in the Python course, yes, lasers use beams, yes? They send beams all around in order to measure distances, yes? In this case, our robot, our LiDAR sensor that we have mounted on the Tatterbot robot, it sends 720 different beams. Yes, do you remember this from the Python class we did on Tuesday? Then here you can see a representation of the 180 degrees that this LiDAR is covering, and the beams, all the beams here, which come from the first one here at the position 0 at the right side of the robot to the last one, which is the position 719. So this covers all the 720 beams that the LiDAR sensor is sending throughout the space. Yes? Then, if the laser beam doesn't collide with anything, the reading I'm going to get is going to be infinite. Yes, because the beam is not going to find any obstacle in its way, so the reading is going to return me an infinite value. But if the beam collides with an obstacle, like in this case, yes, so in the position 360, which is the front of the robot, the beam here is going to collide with this wall. So in this case, the laser is going to return me the distance from the frame of the laser, which is the center of the robot, where the, not the center of the robot, but where the laser is mounted, to the obstacle. Yes? So, for instance, let's say that the readings here to the right side of the robot, here, this wall is going to be printed in the first positions of the array. The ones in the center, at the end of the array, here, 719, are going to represent the readings at the left side of the robot. Here, yes? And the readings at the center of the array, position 360, are going to represent the readings in front of the robot. And what are these readings? The readings are this array of values. So this number here, the first value, this is the value, the position 0 in the array, the first reading. So this means that if we come, this is the 0 position, if we check here, this image, the 0 position is at the right side. So this means that here, this wall is at 0.7 meters from the robot. There is 70 centimeters, so 0.7 meters, from this wall to the robot. Yes? If we go to the last reading here in the ranges array, the last reading, let's come here. It's somewhere here. Here we have it. The last reading corresponds to the 790 position, so the left side of the robot. Then this wall is at 0.68 meters from the robot. And this wall in front, we would need to go to the center of the, I don't know exactly which is the position 360, but here inside the ranges array, we have exactly 720 different readings which correspond to all the beams that the laser is sending. Yes? Then you need to use this information to detect, to know the environment of the robot, and to make it decide where to move, where to turn, and finally reach and exit this maze. Yes? So this is basically the presentation of this program. You have everything you need in order to solve it. Yes? So let me know. This is basically done. We are done with the presentation. Yes? So let me know here in the comment section. Let's see, what are you asking here? Let me check here. Nabil here is saying, could you do another ROS Learning week? Maybe an advanced one. I am looking forward for another week. I already subscribed and will turn on the bell. Okay, thank you very much, Nabil. Yeah, we will think about it, about doing another learning week. We have to discuss about it and we will decide what we do. We will let you know in any case, yeah? Okay, yeah, I can see here Bill in Seattle. So Bill is asking, Isodom's, I lost the question. Isodom's position X to the room or robot? Is X always straight ahead? Okay, so let's do one thing. Let me show very quickly this. So at the beginning, I'm going to reset the simulation to its initial position. Here. Gazebo, reset world. Yes, and then I'm going to get one reading from the topic. So, well, actually, let me, okay, yeah. ROS topic echo odom minus n1. So here I can see that the position right now it's 0, 0, and 0. yes, 0x, this is a 1.3, this is a negative exponential, so this is basically a 0 as well, 0.0000 whatever, so this is 0, 0, and 0, yes? This is because now the robot is in the initial position. So now, what I'm going to do is to move it until the first square here, until this line here, yes? So, ROS launch, I'm going to move it manually. Dot launch. So I'm going to move it forward manually here, real quick, in the x-axis, yes? Forward, I'm moving it manually forward in the x-axis. So now, let me stop it here. Now I'm going to check one more time the odometry, what it says now. Now you can see that the x value has changed to almost 1. It's 0.96. Yes? So the robot has advanced 1 meter forward in the x-axis. And the y and z are still 0. Yes? If I keep moving another meter, here, let's keep moving forward and stop right there. Let's get another reading from the odometry topic. Now it's 2. So I have moved 2 meters in the x-axis forward. Yes? So this is called the position is measured here in the odometry topic. Yeah? Let me check here. Okay, too many comments now. I cannot. Let me check here. Does the we are going to need some days to digest all this knowledge. Okay, yeah, I know. A lot of new concepts, Lisandro, but you are going to be able to do it, I'm sure. Gracias, Alberto. You are a great element for your company. Keep up the good work. Thank you very much, Felipe. Thank you very much for your words. How to stop a robot after publishing some speed at command belt topic without publishing 0 values? Well, there's no way. You need to publish 0 values. You need to tell the wheels to stop moving. Otherwise, the robot is not going to stop. Never. Thanks for a great week, says Team B. Thank you very much. Thank you very much, and you're welcome, Team B. The lesson have been very interesting. Alberto explains very well. I have already subscribed to the Academy to learn during the quarantine. Thank you very much, Andrea. Thank you very much. Andrea Gomez is saying these very kind words. The beam has values of 0, which does not make sense. Where it has values of 0? I haven't seen them. Scan. Minus N1. I don't see. These are the intensities. If you refer to these ones, these are the intensities. You don't need to pay attention to this. You can ignore these array intensities. You need to pay attention to this one. To the one which is above, the one which it's named ranges. Yes, this one. Whoop. Ranges array. Yes, not the intensities, but you need to focus on the ranges array. All right. So, many comments. Okay, thank you. Okay, so I think I'm going to leave it here, and because there are too many comments, I think here that my colleague also is answering all of them, so I don't want to repeat myself. So yeah, guys, if you have questions, remember that we have. Let me show it to you. In fact, very quickly. Well, I'm not going to be able to access it. I think. Oh, it's a pity, but we have the Discord channel, so. All of you can go to the Discord channel, and there we have many channels available, so that you can ask questions there and work with other colleagues in order to solve this problem. You can also ask questions we are going to try to answer them to you. Yes, but yeah, I would recommend all of you, if you want to solve this challenge, I recommend you to all go to the Discord server, to join our Discord server, and there you can ask and work together with other people in order to combine your ideas, combine your codes, whatever, so that you can solve this all together. Yes, because it's going to be much more easier if you share your work and your progress with others than if you try to do it by yourself. Yes, so let me just come here and switch back to my very pretty face. So yes, it's time to end this learning week. We have had some hard moments with problems in the platform, but we have come back stronger and overcome these problems. So at the end, I think that everything has gone pretty well. I've loved giving these classes and sharing all these days, these 2 hours with all of you, and trying to explain and share with you my knowledge. I have done my best in order to make you easier the process of learning ROS, which is by itself a complex thing. So I have done my best. I hope you've learned something with me. And also from the company, we want to thank you, all of you, for trusting in us. We have there's been a lot of support during this week. Many of you have attended these live classes. We weren't expecting at all as many people. In fact, some of the problems we have are because we weren't expecting too many people. Yes, so we want to thank you very much for your support, and we are going to think about it during the following days. We are going to have a summary and think about how this week has gone. We are going to think about maybe repeating this learning week. I don't know. We need to discuss about it. But yeah, at the end, basically we want to thank you all for trusting in us and for supporting us. And basically that's it. So thank you very much for this week. Also, stay safe. So this is the last day, but I'm not going to forget to say it. Stay safe. Stay home. Yes? So keep pushing your ROS learning, but keep pushing it from home, from your computers, from your laptops. But we still need to fight a little bit in order to win this fight against the COVID-19. So we are all together in this as well. And yeah, so that's all from my side. Thank you very much, and I will see you very soon, probably. So goodbye, and keep pushing your ROS learning. Bye bye.